Hello, in 4H&H here. I want to show you some automation. I've got a lot of requests, questions really, about amplifiers, tuners, and such as that. And, everybody's wanting that fully automated experience. It is kind of nice to have, for example, a tuner that can track your VFO. I've had one of those. One that you just give it a quick key down and motors spin and give you tuning. And so, and for that matter, once you, what I call, train the tuner, when you go to the frequency and maybe you start talking, the tuner will figure out what frequency you're on, and it will automatically spin the motors, and you just give it a second, or a few seconds. Sometimes it could take up to 20 or 30, but let it, find the match, and then you're ready to go. And so, what I want to show you is why I'm not replacing the tuner. If you've been following my channel for a while, you know that I had a Palstar AT Auto, and it was a good tuner for many, many years. And I didn't even really know what I was missing. And when I say missing, it served me very well, just about would tune anything. It did struggle a little bit on the on 10 meters with one of my antennas, but this tuner and this amplifier has no trouble with that. But my point is, I am still probably going to get that tuner fixed, but I've been running the internal tuner in this Elecraft KPA-500 for quite a while. I'm a huge fan of Elecraft amplifiers and tuners, as a matter of fact, and those of you who have been following me for a while know that. Many of you have purchased the, well, I say many, quite a number have purchased the Elecraft KPA-500/KP or KAT-500 combo. That's the KPA-500 amplifier, which is a 600 watt amplifier technically, along with the KAT-500 matching tuner. And it gives you similar automation to what you're going to see here. This rig has the tuner built into the RF deck, which is what you're staring at. Now there's a separate power supply over on the left. I'll pan over there and let you see. If you're new to this channel, you haven't seen it, but there's the power supply that's producing the 50 volts DC that this legal limited amplifier is going to require. Now, just for to give you a little bit of an insight, I don't usually run this thing much more than 600 watts, maybe 7, because really much past that, people on the other end are not going to really see much difference on their S meter anyway. And I've said it many, many times, you get most of your increase from an amplifier in that first 400 watts. So for example, if you've got a KPA 500, which can produce 600 watts, even a little more than that, you're already hitting that 400 watts I'm talking about, where you get really the biggest return on your investment. And then you've got some, couple of hundred watts to spare. But that's not what the video is really about. What I want you to see is the automation. So when you think about a tuner, for example, like I described before, you got motors. Once the tuner has been trained, in other words, I go every band, every 25 kilohertz, I key down a 20 watt AM carrier, and I let that tuner do its thing, and remember, it'll record that, into its memory. So the next time I go to that frequency, if I speak or give a quick AM transmission, but even on sideband, just speaking, the tuner will detect what frequency I'm on, and then it will spin up and take me to the correct parameters that it needs to give me a good match on that particular frequency. So this takes it to another level, because this uses the relay bank to pull in and out different inductance and capacitance to achieve the match. But the same thing, I go through every band, every 25 kilohertz with this unit, and I key a 20 watt carrier, and I let the tuner train itself. And then when I come back, this is what I get. I want to show you my operation. So I'm running the FTDX10. I'll pan over to it right quick. Over here on the other side, you can see the display up there, and then down there in the lower right, you're seeing the rig. So I'm going to be pressing the band button on the rig and change bands, but I'm going to have you watch the amplifier up here, which again, this is the KPA-500 from Elecraft, and so it has a built-in ATU, as it's called, antenna tuner. Okay, so let's first of all establish the fact that we're not really tuning the antenna. We are transforming whatever the impedance is coming in off of the, let me get this thing to where you can see the display better. Okay, I took a moment there to get everything focused so you can see everything very clearly. So the, again, let me reiterate, this is not really tuning your antenna. The internal ATU, you see here it says ATU tune. It's just become an industry standard that we refer to antenna matching units as antenna tuners. So let me give you an example of an actual antenna tuner. If you're familiar with Yaesu's ATAS system, the mobile antenna that connects to, so, you know, for example, an FT891. And that antenna actually does tune itself when you, as you change bands and tune around with your FT891, you know, for example, installed in your mobile. The antenna will adjust itself, the length up and down, longer, shorter, according to the band that it's on to arrive at a good match. That truly is tuning the antenna. These devices that we call antenna tuners that are inside the radios these days, or even in a unit like this, are really transformers. So they're taking the various different impedance measurements that you're going to get depending on what band you're on with an antenna. Now remember, we're operating an antenna on a band it's not truly resonant for. These are simply transforming whatever the impedance is at the coax to 50 ohms, so your radio, or in this case the amplifier, is happy and will deliver full power into the load. You're still going to have losses in your coax, but don't get too hung up about that. I mean, I use a tuner on mini bands and I communicate just fine. And the notion that you lose a lot of power in a tuner, that's just a bunch of, well, as we say here in the South, hogwash. So don't get too worried about using a tuner. Now, if you've been watching my channel a while, you know that one of my favorite antennas is my doublet. That's because it's fed with ladder line, and you will get less loss even with a high SWR when you're feeding the antenna with ladder line. Okay, subject of another video, but just wanted to throw that out there. So just know we're not really tuning the antenna. We're transforming impedance from whatever's coming off the end of the coax into this unit, and then we're transforming that over to 50 ohms because that's what the radio, or in this case the amplifier, wants to see. All right, so with all that as a backdrop, let me show you the automation you can expect with a system like this. Remember, I'm coming from a tuner where, yes, I can go ahead and have it train itself every 25 kilohertz, every band, so that it has some memories to recall, and as soon as it figures out what frequency I'm on, it'll ask me to stand by and let it spin up, and it'll, as soon as the motor stop, it'll give you an indication in the display that you're good to go. So this tuner works differently because it's, again, relay driven, and it's switching in and out various capacitor and inductor circuits to arrive at the match. So hint, hint, it's going to be faster than waiting on a motor. All right, so right now I'm on the 20 meter band. I'm just going to leave it trained on the tuner though, so you can see how quickly I will be ready to go if I change bands. So I'm going to go from 20 meters to 18 megahertz, that is the 17 meter band. Notice what the tuner did. Now, talk about automation. It's in bypass. It's on antenna 2. That's my doublet. It is in standby, which is good. Notice that it says 18 megahertz. It's ready to go. Now, why is it in tuner? Why is the tuner in bypass? Because I have predetermined, checking the SWR, that my doublet is actually resonant on this band. It truly is. So I don't actually need the tuner. Let me illustrate that right quick. I'm going to go ahead and send out a test so I can ID. N4, H&H, testing. Did you see the SWR meter right here? Watch it again. November 4, hotel, November, hotel, testing. It's very low, like a 1.1 to 1-ish SWR without the tuner on that particular antenna. Now, if I wanted to, I could force it over to antenna 1, which is my ZS6BKW. Now let's check the SWR there. N4 H&H testing. Okay, so it's a little bit higher on that antenna, but that antenna, what's good about that antenna, and I've featured it many times on the channel here, is it is resonant on 29.6 to 29.7, that FM portion of 10, no tuner needed. It's resonant on 12, 17, as you just saw. Now, it may hit 1.5 or 1.6 if you go across an entire band. It may, span up to that range, but that is still considered acceptable. So 12, 17, 20, and 40 meters, no tuner required. And so now the other bands are available to use as well if I do allow the tuner to touch it up. So that's a cool thing about that antenna. Now, as far as on the doublet is only resonant on 18 megahertz, 17 meters, but it's quite resonant. Now, subject of another video, but I'll give you a quick reason why. I actually, after I did the videos, where I was trying different balance with that doublet a few months ago, I went ahead and trimmed a little bit of the excess ladder line off because I found the resonance was between 14 and 18 megahertz. So I thought, well, why don't I go ahead and let it be really good on one band? And so what I did was I trimmed the ladder line, because if you trim it in 1/8 wavelength increments, up or down, you can change the resonant point of the antenna. So I just trimmed, I think I trimmed about 4 inches at a time until I saw it center up in the 17 meter band. So that's why it's so resonant there. Wasn't exactly an accident, because the resonance was really falling in between 20 meters and 17 meters. And by the way, it wasn't bad. It was less than a 2 to 1. So it was usable in either of those bands. But I just decided, well, go ahead and trim it up and let it center up on one particular band. I do like 17 meters. Okay, so now you saw what it did there. It's going to go back to the last antenna used. So, for example, I'm here on antenna 1 now. I'm going to change bands again. I'll go back to 20 meters. See, it goes back to antenna 2. That is my, usually that's my best antenna on the 20 meter band. And you notice that it's also got the ATU engaged, so it knows that on that band I'm going to need the tuner to provide a match, and that is the case. I do not have perfect resonance on that band. So now I'm going to go back to 17 meters. Okay, there we go. Notice it returned to antenna 1 because that was the last antenna used. There are settings in the menu to set all this up, and that's my choice. But I'll go back to the doublet, and then it would return to the doublet next time. To be honest with you, sometimes one antenna is better than the other. Quite often, I'm better with the ZS6BKW on the 17 meter band, but sometimes the doublet wins. Now, let me bounce around a couple of more, and then I got a final one I want to show you before I end the video. That's really cool. So I'm going to go to the 80 meter band. 3.5 megahertz shows up there on the display. Notice that it goes to antenna 2 on the 80 meter band. Hands down, the doublet wins. Okay, it's quite long. This doublet is 250 feet of wire, so technically it is cut for 160 meters. So it's got a little bit of gain here on the 80 meter band. Could I use the ZS6BKW? Yes, and notice that it knows that the last time I used that antenna on this band, I needed the antenna tuner. It remembers all that. But again, my go-to on this band is going to be the doublet antenna, my antenna port 2. This particular amplifier has 2 antenna ports to pick from. Interestingly enough, the KPA-500 with the KAT-500, you will have 3 antenna ports to choose from. 3 antenna ports. The KAT-500 tuner has 3 antenna ports on the back, and so you can do what I'm doing here, but you have a 3rd antenna option. It's just an unbelievable value in amplifiers, and Elecraft does not pay me to tell you this. I don't even know if they know that I tell you the folks this, but remember about my channel, I'm always going to be honest and tell you to the best of my ability and my knowledge and from my experience what I believe is the best for your money, because I have to spend my money wisely, as I would imagine you do. So I'm only telling you these things because I totally believe what I'm telling you to be absolutely the truth. Just let me show you some more automation. I want to bring this in for a landing and show you something really, really cool that this thing will do. So I'm going to switch over to the 60 meter band. Yes, this will work on 60 meters. So 60 meters on a Yaesu rig is programmed into Memory Bank 5. So if you own a Yaesu radio, you have to access the 60 meter band through your memory channels, because they're already programmed and they have all of the rules programmed, because we have to share that band with the government. And I've got a whole video series about that, 3 parts. So we have some rules to play by there. So Yaesu went ahead and programmed those frequencies in. Basically, there are 10 channels, 5 for sideband, 5 for CW, and they've got them programmed into Memory Bank 5, playing by all of the rules, except one. We are responsible for the power output, which has to be kept at 100 watts ERP. So I'm going to go to memory mode on my FTDX10 here, and I am now on the 60 meter band. Now you'll notice that it's saying 7 megahertz. That's just the way this is going to work. Don't worry about it. That's just one little idiosyncrasy with this. I don't know. I haven't asked Elecraft why, because it doesn't matter. Watch this. I'm wearing my headset, my Heil Pro Set Elite 6. I usually use it on the FTDX10. I'm just going to start to talk. Okay, I'll throw my call sign out. Let me make sure nobody's on here. I'm listening through the headphones. There's nobody there. Going to turn on Vox. And then just watch what happens when I talk. N4 H&H. N4 H&H testing. Okay, by the way, it was going up to 100 watts, and you saw the SWR was very, very low. And now it says 5 megahertz. It doesn't default to 5 megahertz until it detects the frequency I'm on, and apparently the radio is not sending it that particular band, because I do have the Elecraft cable. That's what makes all the magic work. You have a special cable from Elecraft that plugs into the back of your rig. You just tell them what rig you have, and that cable is going over to this amplifier. Now, in the case of a KPA-500 / KAT-500 combo, the cable goes to the tuner, and then there's a shorter cable from the tuner to the amplifier, and then they work just like what you're seeing here. They work together. So it uses BCD, binary coded decimal, coming in on the wires to tell it what band to go to. So the only thing I can think of, I haven't asked, like I said, is the radio's not sending it the binary coded decimal information to let it know that it's the 5 megahertz band. Well, apparently what it is sending is 7 megahertz. But as soon as I spoke, the frequency counter inside of this unit here detected that I was on 5 megahertz, and it chose the appropriate parameters, and I was ready to go. I mean, literally within a syllable, it was, I mean, nobody would have even known. That's full automation, and that's how this thing works everywhere. That's the worst case scenario, is where I have to speak and let it, adjust itself. But it does it in a split second, as you saw, and it gave me a perfect match. So, all right, I'll do a couple more just so you can see the automation. I'm going to go to 160 meters. Just came out of memory mode, and it took me back to 80 meters where I was. Now I'm on 1.8 megahertz band at 160 meters. Notice it is using the tuner, the internal matching unit here, and it is on antenna 2, which is my doublet. It's ready to go, actually. But I'll go ahead and throw out a call. N4 H&H testing. You see, I don't have to do anything. It goes ahead and dials it up, and I'm ready to go. So that's the automation that many of you are seeking, and I know some of the tuners out there from various manufacturers, I won't mention it, but you've got to go, even though you've programmed a bunch of memories in there, you still have to press some buttons. This is easier because all you do is 20 watts AM, give it a carrier every 25 kilohertz, let it train itself, memorize, in other words. And then from then on, you just change bands and talk. That's the ultimate automation. So for those of us like me who chase soda stations and DX, and they're all over the place, all these different bands, I don't want to have to wait on a tuner. Certainly don't want to have to wait on a manual tuner, but I don't even want to have to wait on a tuner that has to spin up motors and tell me, you know, QRT until it finishes. This is all instantaneous, bouncing from one band to another. So let me bring this in for a landing. I'll do a couple more. I'm going to go to 15 meters. Notice it chose the doublet. It usually is my best antenna on 15 meters, so that's where I left it last time, and therefore it recalled the doublet, and it knows it needs to have the matching unit. Okay, they call it an ATU. But remember, it's just acting like a transformer. But it knows that it needs it for the doublet. So again, I'm going to press Vox. N4 HNH testing. N4 HNH clear. Now, did you catch that? If you didn't, rewind. You'll see it jumps up into the yellow there for a split second, and then it detects the exact frequency I'm on. What happened there is when I switched bands, it picked some set of parameters from previously when I had it memorized every 25 kilohertz. But once I spoke, it saw exactly the frequency I was on, which was 21.240, and it basically checked its memory bank, and it says, ooh, I have a better match for that, and it loaded it instantly. That's what I mean. I mean, you just start talking, and even if it has a better match in memory, it'll go get it. It's just unbelievable. Okay, so again, in the case of, well, let me show you one more, 10 meters. And the reason I want you to see 10 meters is because my old PAL-Star was not able to tune this portion of the 10 meter band, the 28.3 to 28.5 sideband portion. So let's see what happens here. I will tell you, I've already trained the tuner, so you got a clue what's about to happen. Here we go. I'm going to Vox. Notice it's got the doublet selected. N4 HNH testing. I'm ready to go. As a matter of fact, I didn't even hear a click. It actually was satisfied with the match that it loaded when I changed the bands. So I'm going to leave you with that 60 meter band again, because it's the only one that plays a little bit differently. It waits on you to talk to even change bands. But let's watch how fast it does it. So I'm going back to memory mode. I'm going to notice it's on 7 megahertz. And on 7 megahertz, I use the ZS6 BKW. It always wins on that band on 40 meters. It is in bypass, okay? Let's see what happens when I talk. N4 HNH testing. N4 HNH clear. Did you see that? Once it detected that I was transmitting on 5 megahertz, it went into its memory bank and said, whoa, 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 I got a better match. But I'm going to need the ATU. So it automatically engaged the ATU and loaded the match. In other words, clicked the proper relays to get the correct capacitance, inductance combination, and therefore gave me a great match. And I'm going to give you a little tidbit here for those of you who have watched the video this far. Let me give you a little inside info if you're new to amateur radio and you haven't heard this before. The way an antenna tuner, okay, matching unit works is it will use inductance to make the antenna seem a little bit longer than it really is. Now think of inductance as a coil of wire. So if you think about like your mobile antennas that have those coils, that's so the antenna can be physically shorter but appear electrically longer, right? So we know that adding more wire in a coil makes the antenna appear longer than it really is. The same thing is happening inside the ATU in this unit. So what does the capacitance do? The capacitance makes the antenna seem shorter than it really is. So if you've got an antenna that's a little bit too long for a particular frequency, then the ATU is going to use a capacitance to make the antenna appear shorter. So just remember it that way, file it away if you're curious. the way antenna tuners work, it wouldn't matter whether it's manual or automated, whatever. They add inductance to make the antenna appear longer than it physically is. They add in capacitance to make the antenna appear shorter than it actually is. Okay, so there's your little a little bit of a tidbit there at the end. I appreciate you watching the video, and thank you to the Patreon team who make these videos possible for me to bring to you. Without them, I certainly would not be able to do this. So thank you so much to the Patreon support team. If you would like to join that team and help me bring more videos like this, go to www.patreon.com/N4HNH. That's patreon.com/N4HNH. And do me a favor, share this video with your friends who you think would benefit from this information. And finally, please, if you would, like this video, smash the thumbs up, and subscribe to the channel. That helps us out here with YouTube standings. I really appreciate if you'd do that for me. Click the like button and subscribe to the channel. If you do subscribe to the channel, be sure to click the notification bell, bang that bell, ring that bell, right? So that you can be updated when I upload a new video, which is generally 1 a week and sometimes 2 a week. Again, thanks for watching, and 73 from N4HNH.